What's the radius? 7 times 10 to the power of negative 11. Okay. And then for part 2, what is the answer? 7 times 10 to the power of negative 11 also. Okay. Alright, so in part I and part 2, you have already expressed the respective radius in meters, okay, into standard form. In part 3, express A is to B as a ratio of two integers in its standard form. Okay, so that means that for any ratio, we always need our quantities to be of the same unit. Okay, so we're using our answers in part I and part 2. Okay, and then after that, you want it for ratios, it must be in integers. Okay, so therefore, because both of it are times 10 to the power negative 11, whenever we're simplifying ratio, we divide both sides by the same value. So I can divide away by 10 to the power negative 11. In other words, it can simplify to 7 is to 7.4. But this is not an acceptable ratio because ratios must be whole numbers. So in this case, to simplify it, you could rely on your calculator, take 7 divided by 7.4, okay, and then you can get a fraction. That will be the answer. Otherwise, you can do the long way, times 10, you get 70 is to 74, then divide by 2, sorry, I'm doing this mentally, so 37, right? Yeah, okay, divide by 2, you get 35 is 37, and that will be the simplest form already. There's no other common factors. Okay, so that will be the answer. Okay. Then looking at question 13. It says that light travels at a certain speed, expressed into standard form, given that the mean distance from the Sun to Jupiter, mean distance is 778.5 million km. Find the time taken. Okay, the speed was given to be 3 times 10 to the power 8 meter per second in standard form. Right? So to find the time taken, what you need to do? Use your DST. Okay, distance, speed, time, triangle. So to find time taken, distance divided by speed, okay? But the problem is that this is in kilometers, this is in meters per second. So you got to make sure that the units are similar in the sense that this got to be in meters. So you need to do some unit conversion first. Okay, so the distance 778.5 million would mean times 10 to the power 6 kilometer. Kilometer change into meter, you need to times 1000. Okay, in other words, times 10 to the power of 3. Okay, so you will get 778.5 times 10 to the power of 9. Okay, this is not standard form, right? You may want to write it into standard form, but it actually doesn't matter. So if you want it in standard form, then you will get times 10 to the power of 2 first, then times 10 to the power of 9, right? It's then 7.785 times 10 to the power 11. Okay, so not necessary to convert it into standard form. You can leave it like that because our objective is to find the time. All we need is the meters. Okay, so the time taken would be distance, which is 778.5 times 10 to the power 9 meters, divided by the speed, which is 3 times 10 to the power 8 meter per second. Okay, and that will result in, this one, 778.5 times 10 to the power 9 divided by 3 times 10. That will give us 2595 seconds. Right? Question needs it to be in minutes and seconds. So 2595 divided by 60, that will give us 43.25 minutes. And 0.25 minutes convert it into seconds, we times 60. So therefore 43 minutes and 15 seconds. Okay? It is not 43 minutes and 25 seconds. So 0.25 minutes convert into seconds, we need to times 60. Okay? Questions? If you're okay, could you please pass your homework down to the front? So we're still on chapter 4.1. Okay, first of all, do you know what's a polynomial already? No? Okay. Okay, maybe just do a very quick recap. Okay, in general, what a polynomial is, okay, got some examples. Okay, you have, for example, your quadratic expressions, your 2x squared plus 3x plus 5. This is an example of a polynomial. Okay, you can go higher powers than just power of 2. Okay, we can have things like maybe 7x cubed, okay, minus away 0.2x plus 8. Okay, this is also a polynomial. Okay, then we can also give up to maybe 1,000. Okay, negative 1 over 8x to the power 1,000. Okay, plus maybe 3x to the power of 999 minus away 5x to the power of 175 plus 6x to the power of 20. Okay, this is also a polynomial. So essentially a polynomial, okay, must have powers that are integer numbers. Okay, the coefficient itself, the number in front, okay, need not be an integer. It can be a fraction, it can be a decimal, alright? It just has to be a number. So these are what we call polynomials. Okay, there is a formal definition for it. Okay, maybe you will see that in your textbook. Okay, they indicate all the coefficients with a number that's called a, and then a 0 at the bottom, just to indicate that there are many numbers. Okay, so you can go from a constant term all the way to a term like that. So that is your polynomial. Okay, we need to know how to identify the degree of the polynomial. Okay. Because later on, when we cover deeper into chapter 4, knowing the degree of polynomial is important. So for example, in this example over here, degree of polynomial refers to the highest power that can be found inside it. Okay, so in this case, the degree is 2. Okay, then in this case, we have degree 3. And then over here we have degree 1000. Okay, so that is how we identify the degrees of polynomials. Okay, definition, highest power. Okay. Questions? Right? Then you would have learned how to expand polynomials already. That one is just doing your rainbow method. Okay, your distributive law, just expand only. Okay, I hope that is okay. Alright, then after that, identities. What exactly is an identity? Okay, essentially it's just telling you that the left hand side of an equation is equal to the right hand side of the equation. Okay, that two things are equal. Alright? So that is what identity means. Some identities that we have already learned previously in set 2. Okay. This is an identity. Although maybe we call them formulas. Okay, so these are just some examples of identities. They are essentially things that are true for all values of A and B. Okay? So whatever A, whatever B you put in, the left hand side will always be equal to the right hand side. That is the meaning of an identity. But you don't need to harp much over this understanding of identity. Okay? So you can just see it as an equation, that's all. Right? Then let's go into division. Okay? Okay, let's look at try 6 in division. Do you remember how to do long division in primary school? No? Yes? We did long division in primary school, right? So the idea is the same. Okay? So let's just do a very simple division. 29 divided by 3. Okay? We know that 27 divided by 3 will give you a whole number. So we will choose 9. Okay? Then after that 27. Yes, Isaac? Yeah. Okay? Then after that we minus away, right? So 29 minus away 27, that will give us 2. Okay? So we can tell us from here that 29, okay, divided by 3 gives you 9, remainder 2. Alright? This is what we learned in primary school, right? Okay? In other words, I can also say that 29 is equals to 9 times 3 plus 2. Okay? 9 plus 3 is 27. 9 times 3 is 27. Then you plus another 2, that will give us 29. Okay? So the components found inside this long division are such that this is what we call the dividend. The thing that gets distributed, that's your dividend. Okay? This is your divisor. This is your quotient. And over here is your remainder. Okay, these are some important terms that you may encounter as you solve a problem. Okay? So using that, maybe let's do another long division that we learned in primary school using numbers first. So what if I take 502 to divide by 3? How do we do this in primary school? How do we do this? 502 divided by 3? 5 divided by 3 first, right? For which we will choose 1, right? Okay, then after 3 over here, we will be left with 2. Alright, 5 minus away 3. Okay, then usually what we did is put 300 over here, 0, 0. Okay, then after we bring down, right, the 0 and the 2. Alright, you all remember this? This school? Okay, if you remember that school, if you don't remember, then okay, it's a refresher of your memory, okay? Alright, because you are so used to calculators nowadays, really, right? Okay, so that's why these things we don't remember. But this is an important mechanism for us to do our long division of polynomials. Okay, so 202, then we divide by 3. We look at the multiples of 3. 20, we will choose 18, so that's 6. Okay, so 18. So 20 minus away 18, I'm going to get 22. So this 2 is being brought down, right? Okay, then 22 divided by 3. The next multiple is 21. So that's 7. Okay, 7 times 3 gives us 21. So minus, so it's always a minus. Then we get 1. So the remainder is 1. So in other words, with this long division, we see that 502 is equals to 3 times 167 plus 1. Okay? That is what we understand from this long division. Other than knowing it as 502 divided by 3 equals to 167, remainder 1. Okay? So using this idea, let's look at try 6 again. Okay, we want to find the remainder and the quotient. Okay, so we are taking this polynomial 3x squared minus 2x plus 5. divide by x minus 2. Okay, so 3x squared minus 2x plus 5 is the dividend. Okay, I'm not sure why this boy is walking around the entire classroom for very long. What's the boy's name? Today, please circulate yourself out of my class. I can see you using your phone there. Okay, 3x squared minus 2x plus 5 is our dividend. Then we're trying to divide by x minus 2, so that's our divisor. So how do we go about doing this long division? Okay, same thing, we focus on the first thing that comes in front, 3x squared. Okay, we're trying to divide by x minus 2. Of course, if you see x minus 2 as a whole thing together, it's difficult. We focus it on the x only. Okay, I want to slowly, okay, like what we did over here, move from this first digit over to the last one. Try to eliminate things, remove things. So this 3x squared, I want to try to get rid of it. Okay, and how do I get rid of it? I need to take a number, multiply by this, such that I can get a 3x squared. Okay, so I want a 3x squared from here, because then I minus away, no more 3x squared. Okay, so what multiply with x will get us a 3x squared? A 3x, huh? Okay, so 3x times x, I will get a 3x squared. The minus sign comes naturally because of the way we do long division. It's always a minus. Okay? But not forgetting that 3x doesn't just multiply with x, it also needs to multiply with the minus 2. Okay? So 3x times minus 2, that will give us negative 6x. So I'm subtracting the entire 3x squared minus 6x. Understand? Okay? Then after that, what will be left? 3x squared minus 3x squared, no more already. Okay? Minus 2x minus negative 6x. In other words, it's negative 2x plus 6x, so 4x. Okay? Then we carry down the plus 5. Alright? Let me get a red marker. Carry down the plus 5. Okay? Then 4x plus 5. Okay? I need to look at this divisor again, x minus 2. Okay? Can I continue dividing? How do I know when to stop? Okay, that's the important thing. How do I know when to stop? Looking at the way we do long division, it is when the number over here becomes smaller than our divisor. Correct? Because 1 can no longer be divided by 3. Okay, if I have a number 4, I can still remove 3 out, right? Okay, if I have number 5, I can still remove sets of 3 out. Okay, so I stop my long division when the number over here is smaller than this. So for expressions like this, for polynomials, I stop when the degree of the polynomial is lesser than the divisor. So this is a degree 1 polynomial. Because the highest power is 1. Okay, so 4x plus 5 to divide by x minus 2, to think of what can help me to remove the 4x, I will plus 4. Because 4 times x, I will get a positive 4x. Then when I minus, my 4x disappears, right? Then 4 times negative 2, that will give us a negative 8. So I'm subtracting 4x minus 8. So what I will be left with is plus 5 minus away negative 8. So that will give us positive 13. Okay? And this is a degree 0 polynomial. Because the highest power of x is actually 0. Okay? Since it doesn't exist. Right? Questions? Okay? So this is how we do our long division. Then to answer the question, to find the remainder and the quotient, the remainder is this thing here, which is 13. Then the quotient will be 3x plus 4. Okay? Questions? Need me to do one more? Or your try? Okay, your try, huh? Okay, let me find question. Okay, could you please do question 5B? Of your exercise 4.1. Okay, could you please work on this? I give you about 3 minutes. Okay? Not forgetting we're trying to subtract the entire expression over here. So 4x cubed is no more. Then 8x squared minus away 2x squared. That will leave us with 6x squared. Okay? Then we bring down 7x and minus 5. Right? Okay? Then now we see that the degree of this polynomial over here is highest power is 2. So this is degree 2. Whereas over here degree 1. So this is still more than this. So I need to continue. So what I'll need to do is I'll plus, okay? In order to get 6x squared, I will have to multiply by 3x, okay, to 2x. In order to get a 6x squared over here. So 3x times 2x gives us 6x squared. Then 3x times 1, that will give us a plus 3x. Then minus away. So we get this. Okay? 7x minus away 3x. So minus over here. Minus away a positive 3x, that will leave us with positive 4x. Okay? Minus 5. The power here, the degree over here is 1. It is still not yet less than this degree. So I need to continue. I will need to plus a 2 over here. Okay? So 2 times 2x, that will give us a 4x. 2 times 1, that will give us a plus 2. So minus 5 minus positive 2, that will give us a negative 3. Okay? So therefore, we stop over here because the degree of this polynomial is now 0, which is less than 1. Okay? So, ending here, our remainder, to answer the question, it will be negative 3, and the quotient,
it's negative 7.
oh, thank you, minus of next things, sorry, negative 7. Thank you. 2x squared plus 3x plus 2. Okay? Yes. Oh, sure. Any other questions? Yeah, Alex. Why is it the remainder is negative number? Now, because we're dealing with division, with polynomials, okay, your remainder can be negative. It need not always be positive. Unlike when we're doing our long division. Okay. Any other questions? Okay. Then let's move on. Okay. Try 7. You're okay with it? Because it is slightly different. Okay, is it okay if I do try 7?
Yeah.
Okay, I do try 7 now. Okay, try 7. We are again trying to do this division. We're trying to find remainder and quotient. Okay, why do I say that it's slightly different? I'll show you in a moment. So again, 4x cubed, to get rid of this, what do I need to multiply over here? 2x squared. Okay, 2x squared. 2x squared times 2x, then I will get 4x cubed. 2x squared times 1, I will get a positive 2x squared. Okay, minus like that. Okay, so 4x cubed minus away 4x cubed, there's no more. But the problem is that in my original polynomial, I don't have an x squared term. I cannot take negative 5x minus away 2x squared. So if you want to, you can leave a space over here such that you arrange, okay, in decreasing order of your powers. Okay? So that you remind yourself that actually there's nothing over here. Right? So actually it is 0 minus away 2x squared, so you'll be left with a negative 2x squared. Okay? Then these two bring down, we get minus 5x plus 5. So this is something that's slightly different from what we were doing earlier on here. Okay? Questions? Then after that, we need to again decide on removing this negative 2x squared. Okay? So what should I multiply over here to my 2x in order to get a negative 2x squared? I need to minus away x, right? So negative x times 2x, that will give us a negative 2x squared. Right? Then after that, negative x times 1, I will get a negative x. So subtracting this entire thing, so negative 2x squared minus away negative 2x squared, they are the same. So this disappears already. Negative 5x minus away negative x, that will then give us plus negative 4x. Okay, we're still not done with our long division here. Since the degree of this is 1, degree of this is also 1, so I can still continue. Then I will need to multiply, what should I choose over here to get rid of the negative ones? Negative 2, right? Okay, so negative 2, negative 4x here, and then negative 2. Right? So 5 minus away negative 2, that will give us 7. Okay, so remainder in this case is 7. Quotient will be 2x squared minus x minus 2. Okay, questions? Can you hold on? Urgent, is it? Urgent, okay. Okay. No questions? Yeah, that's it. Yes, you can. If you want to, you can put plus 0x squared, no problem at all. If you don't want to leave the blank space, also can. Alright? It is just that we're now starting out, so you may want to have things aligned. Okay?
But power isn't like 2, right? But what if it's like 4?
This one is 4 lah. Not possible because down here is lesser power than this one. Yeah. So down here cannot be higher. Yeah. It can only get lesser. Okay, any other questions?
Must the powers be like consecutive?
As in, one after another.
It's like 3.
Usually is. Yeah. But sometimes you can be missing terms of like this case. Yeah. When 3 they are able to 1, you have 2. Okay? Yes. Region.
Possible like
Divide by 2x squared plus 1. It's possible. You want to try that? Both terms. So 2x squared plus x squared plus x. Is it? Okay, let's try that. Why not? Okay. Helps us to reinforce our long division. It's possible. Okay. Alright. Why not you all give me something to divide with? What should our dividend be? Give me anything. But give me integer numbers. Don't give me fraction or decimal. 2x cube.
Square.
Okay, maybe let's go higher powers lah. Okay, 4. Alright, sure. Then after that what? Plus 6. Okay, x to the power of 2. Okay, minus. That's not 2 lah. 7 lah. Okay, x is it?
Yeah.
Okay, then any constant term?
0.
Okay, plus 18 lah. Okay, the 0 is possible lah, but it will not be meaningful. Okay, so Minjun wanted us to have x squared and x inside here. So maybe let's do 2x squared plus x, something like that. Okay, so how will the long division look like? 2x to the power of 4. How do I get rid of this? What should I multiply over here? X squared, right? Okay.
What if 2x squared?
2x squared plus x squared. Then you can simplify what? Become 3x squared. Okay. So yeah, you should simplify that first. Right? So x squared times 2x squared, that will give us 2x power 4. X squared times your x, that will give us a plus x cubed, for which we don't have that term here. Okay. Minus away this entire thing. So there is actually a plus 0 here. Okay, so we'll be having our negative x cubed followed by carrying down the rest. Okay, this will be a fairly long exercise. Alright, then what do I need to multiply in order to get negative x cubed? What do we multiply? You're following or not? What should I multiply over here to get a negative x cubed? Joven? What should I multiply to get a negative x cubed? I just thought about it. I asked just now. Huh? I need to get rid of the negative x cubed. So what should I put over here to multiply with the 2x squared? Negative half x. Right? Okay? So actually, I want to get rid of the negative x cubed. Okay? But this has a 2 over here. Alright? So I cannot be multiplying by integer numbers anymore. Okay, so I need to get rid of the 2, so I should multiply by half. Half times 2 gives us 1. Right? Okay, and then x times x squared gives us x cubed. The minus sign is necessary so that we can have like terms. Okay? Minus sign on the outside like that. Then we continue negative half x with this positive x that will give us negative half x squared. Okay? So now 6 minus away negative half, that will give us 6 and a half, which is 13 over 2 x squared. I prefer to write my coefficients in our improper fractions rather than to write it as mixed numbers because it's a little bit strange. Right, just a convention. Then I'll carry down minus 7x plus 18. Right? So my degree of polynomial over here is 2. Degree of polynomial over here is 2 still. So I still need to continue. Okay? So what should I put over here in order to achieve a 13 over 2? 3 and a half. A bit challenging, right? It doesn't normally happen. 3 1 over 4. Is it? I also need my calculator. No one. Think something. So is that something times 2 will give us 13 over 2. Right? I need to choose a number, right? Okay, 2 times 2 get me to 13 over 2. So that means my number need to be 13 over 2 divided by 2. So 13 over 4. Okay, so I'll plus 13 over 4. Okay, and then I will get 13 over 2 x squared followed by plus 13 over 4x.
Oh my goodness. It's so boring.
But actually it's stopping already. You realize?
Yeah.
This is the last one already. So we will get negative 41 over 4x plus 18. This is the remainder. Now why is that the remainder? Why do we stop here already? Because the degree of this polynomial here is degree 1. Whereas this one is degree 2. Right? We stop once, okay, the degree is less than that of the divisor. Okay? Okay? Right? I think this example was good, although it was random. Help us to make sure we understand our concept. Okay? So making use of what we have just done, okay, we see that earlier on, okay, remember when I was doing the division of 29 divided by 3, I got 9 remainder 2, which I also said that 29 is equals to 3 times 9 plus 2. Okay, how does this structure come about when we do our polynomials division? Okay, so making use of this one over here, what I've just done is to say that 2x to the power of 4 plus 6x squared minus 7x plus 18, essentially it is equals to 2x squared plus x times x squared minus half x plus 13 over 4 plus the remainder. Okay. Okay, so our dividend will always be equals to the divisor multiplying by the quotient followed by the remainder. Okay. Right. So one important thing is that the degree of the remainder must always be lesser than the degree of the divisor. That helps us in terms of our long division. That's when we know that our long division has stopped. Okay. But important to know is that our dividend in this case is a degree 4. Okay. Your divisor and your quotient. Okay. Divisor has a degree of 2. And your quotient has a degree of 2. Okay. So when you were to add up these two, okay, they need to be equals to degree of 4. Okay. The powers, the highest power when they add up must be equals to degree of 4. Why? Because this is the critical part whereby when I do my expansion and my simplification later on, it must get me back to this thing. Okay? Because I'm saying that they are equal one. So if I were to expand the right hand side, it must get me back to my left hand side. Right? So when I were to expand this doing my rainbow method, it is my 2x squared and my x squared that will multiply with each other to give me the x to the power of 4 term. Okay? So to get my x to the power of 4 term over here, it is only when I have 2x squared multiplied by x squared. There is no other way of rainbowing that will allow me to get 2x to the power of 4. Right? 2x squared you multiply by half x, it at most get you x cube only. Because x squared times x gives us x cube. Okay? So because when we're multiplying, essentially the powers are adding up to each other due to our law 1 of our indices laws. Okay? That's why your degrees of these two adding up to each other must be equals to the degree of the dividend. Okay? Alright? Questions? We end at 10:40. See?
Yes.
Okay. Right. I think, okay, maybe let's stop here for today. Alright? Go back home, go and try to let these ideas sink in. Okay, for your chapter 3 homework, which I assigned for HPL yesterday, make sure you get it done by Monday. Okay, so Monday, if you have any problems with it, that's where I make use of the questions to kind of tie up any loose ends for your chapter 3 lah. Okay, because I didn't quite cover chapter 3 with you. So I'll make use of the questions to tie up any loose ends. Okay, or untie any knots that you may have. Okay, whatever problems that you may have. Okay.